All right, sunshines, let's talk about side lengths of isosceles and equilateral triangles. So the easy version of this is if I give you a side length and you know that another side is congruent to it, you just copy it over. If I know that this leg of the isosceles triangle is 83 degrees, then that means, or inches, that means this one is also 83 inches. I know absolutely nothing about the length of the base. I cannot find it from this information. I would need to know the angle measures and use trigonometry in order to find, or know the perimeter and use subtraction in order to find that third side. The biggest trick here is that if I don't give you the pair of congruent sides, but instead tell you that a pair of angles is congruent, then these are the base angles, which makes these the congruent sides. For an equilateral triangle, it's even easier. If I know the length of one side, then the other two sides are the same length. Obviously, the real problems come when I don't give you numeric values, I give you algebraic expressions. So 4x plus 3, 5x minus 5, and x plus 6. It's really tempting to just put anything together. You have to pay attention to which sides are actually supposed to be congruent. This one doesn't have a coefficient for x, so it's really tempting to, you really want to use this, but you can't because the base side of an isosceles triangle has nothing to do with the other sides unless you have information about it. I only know that these two are congruent to each other, so these are the two that I have to use to solve for x. I can't use this one to solve for x. So since they're congruent, that means they're the same length, they're equal to one another. So 4x plus 3 equals 5x minus 5. Now I have an equation that has variables on both sides of my equation, so I need to add and subtract until I get one x term by itself. I prefer to to cancel out the lower x term so that I'm left with a positive coefficient for x wherever I have x left over. Conveniently, this also 5 and 4 are only 1 apart, so my coefficient is 1, so I don't have to worry about dividing out a coefficient. So now I have 8 equals x. So I do end up with it backwards when I do it my way, but if I did it the other way, I'd have to divide by -1, and it's very easy to lose track of that negative sign. So I prefer going this way. So now I know the value of x, but that doesn't tell me the side lengths. That just tells me what x is, which could be my question, but it's usually not. Usually we care about the actual length of some of the sides. So to find those side lengths, we need to plug x back into the lengths. So I'm going to substitute this x with the value 8 because we know that 8 equals x. So 4 times 8 plus 3. So we simplify that and it gives us 35. So segment BA is 35 units long. We know that these two sides are congruent, so we know that segment AT should be 35, but it's always a good idea to plug it back in and double check ourselves and make sure we didn't mess up something along the way. So if you plug it into both of the congruent legs and you get the same value, then you know you did it right. And then the base side is just 8 plus 6 is 14. So we didn't need to use this information to solve for x, but if you're going to find all of the lengths of the triangle, then obviously you need to plug it into that expression. And so we can find the length using this expression. So for an equilateral triangle, all three sides are congruent. So you can pick any pair, it doesn't matter, they're all congruent. And then you do the same thing. So if this side is 4x plus 3 and the side is x plus 18, if you Yes, it magically changed from a 7 to an 8 because I made a mistake. Uh, you set those two equal to each other, solve for x, so you subtract x from both sides, subtract 3 from both sides, divide by 3, all that jazz. You know how to solve equations by now, and x equals 5. And then you plug your x value back into all of the expressions to solve for the side lengths. Again, if you solve for one of them, you actually know the other two. You don't need to solve for them, but it's a good idea to solve all three of them just to check and make sure that you didn't slip up somewhere.